So in this video, we're going to finish up section 3.3. First, I want to just remind you what we learned earlier in 3.3. So we talked about what happens if you get a 0 when you divide. So let's look at this one. If you put a -1 on the shelf and you do synthetic division, where you take these coefficients and you divide and you get a 0 in the box. So 0 is your remainder. Remember, that means that this -1 is a 0 of this equation. That also means that it is a solution. If you set that equation equal to 0 and solved it, -1 would be one of your answers. You could also take this -1 and solve it to figure out what the factor is. So you would just add 1 to both sides. So x plus 1 would actually be a factor of this equation. So having a 0 as your remainder means a lot of things. So we're going to use that. So what we're going to do now, notice this very last problem that we did, is I gave you an equation. I said these are your two zeros, find the other two, because it's x to the 4th. So we know we have 4 answers. So they gave you 2, you had to find the other 2. Well, now I'm no longer going to give you any zeros. You have to find all 4 of them. So how do we do that? We're going to use what's called the rational zeros theorem. And it says if P over Q is a rational number, a fraction, and that P over Q is a 0, then a polynomial function with integer coefficients, then P is a factor of the constant, and Q is a factor of the leading coefficient. Now, what in the world does that mean? Here's my version. When you're trying to find the zeros of a polynomial, I haven't given you any. There are only, we can narrow down all the possible solutions to just a few, okay? So these are the possible solutions to the equation. So it'll just help if we just work a couple of problems. So here's how to find the actual solutions, not the possible ones, but the actual ones. So the first thing we have to do is determine how many zeros you have. So again, remember that means you're just looking at the degree on the equation. So then you're going to make a list of all the possible zeros, and we're going to use what I'm getting ready to teach you, the rational zeros theorem. So you're going to list all the possible ones. Then you're going to graph it using the calculator. So we're actually going to graph on the calculator now. And then look for the x-intercepts and match as many of the x-intercepts of that graph to the possible zeros in my list. Then we're going to use synthetic substitution in to plug in each one of those matches until we get all the way down to x squared. Okay, so let's just work one of these. So here's my equation. Notice that we have x to the 4th. So that means we're going to have 4 solutions. So what this is saying is that P over Q, my possible solutions, is I'm going to take this constant right here. There's my constant, the 4, and I'm going to list all the factors of my constant. So that's going to be, let's see, and then I'm going to list all the factors of my leading coefficient. So let's do that. Here's all my factors of 4. Notice factors of 4 will be 1 times 4 and 2 times 2. So my factors are going to be 1, 2, and 4. That goes on top, so the constant factors go on top. Then let's look at the leading coefficient. The coefficient is 8, so 1 times 8 and 2 times 4. So my factors are going to be 1, 2, 4, and 8. We are going to make as many fractions out of that as we can. So I'm going to take my 1 here, and I'm going to say, okay, I've got 1 over 1, 1 over 2, 1 over 4, and 1 over 8. Whoops, excuse me. So there's 1. So we've got 1, 1/2, 1/4, and 1/8. Then I'm going to do the same thing with my 2. And I'll have 2 over 1, 2 over 2, 2 over 4, and 2 over 8. Now notice that we already have some of those, right? We've got 2 over 1, that's 2. We don't have that. But 2 over 2, that's just 1. We already have that, right? And then 2/4, well, that's just a half. We already have that written up there. And 2/8, we already have that written up there as 1/4. So we don't have to rewrite them. And now I'm going to do the same thing with my 4. 4 over 1, 4 over 2, 4 over 4, and 4 over 8. And I'm going to go back through and cancel out any that we already have. We don't have 4 over 1, that's 4. But 4 over 2 is 2. We already have that right there. 4 over 4, that's going to give me 1. We have that right there. And 4 over 8, that's a half. We've got that right there. So my final list is going to be positive or negative 1, because we could have it either way. Our solutions could be positive or negative. So we have positive or negative 1, positive or negative a half, positive or negative a 4th, positive or negative 8th, plus or minus 2, plus or minus 4. So how many is that? We've got 1, 2, 3, 4, 5, 6 times 2, because it's positive or negative. So we've got 12 possible zeros. Now think about what that means. That means out of all the answers that we could get, if I set that equal to 0, which is an infinite number from negative a gazillion to positive a gazillion, we've now eliminated all but 12 answers. That's pretty good. Okay, so now let's figure out how many we're looking for. How many do we need? Remember, we got x to the 4th. So we need 4 answers, right? So what they're asking is find all the rational zeros. So they want us to find all the zeros. That's the first part. And then they want us to factor. So, but once we have all the zeros, then it's going to be really easy to factor. So let's figure out how to get our zeros. So remember, the first thing we said was A, we need to graph this equation, stick it on our calculator, and look for our x-intercepts. So let's do that. Let's put that in. Now, I've already entered it into the calculator, but I want to show you, since we haven't done this really, I want to show you how to put it in. So I'll start entering it again. You'll put your 8. Oh, how did I get there? So I got there by clicking this, whoops, excuse me, sorry. Y equals, do you see the Y equals button? Okay, so I can't point to it, sorry. So the Y equals button on our calculator, it's above that light blue second button. So it says Y equals. So you're going to click that. That's how you get here. And then you're going to put your 8. And then the X is right across from the green alpha button. You see it says an X, a T, a theta, and an N. So when you hit that button, it will just put an X on your screen. Then the way that you get to the 4th power, look right underneath the button that says clear. The clear button on the far right. Right underneath it is a little TP, a little caret. So I'm going to hit that. Notice it puts my exponent up high. Puts my cursor in up high. Then I click my 4. Now, if I keep typing, notice what happens. See, it just stays up there. So I don't want to do that. So I'm going to come back and delete that. So you're going to hit the right arrow button up at the top, close to Maddie's little peace sign fingers. So you click the right button, and that gets you back down. And then you'll hit minus 26. Excuse me, delete that 26. And I'll go ahead and put my X. It won't let me put the 2 in there. Anyway, there we go. 26, X to the 3rd X. I can do the same thing. Use that little arrow, that little TP, X to the 3rd, and then the right arrow, and then I just keep going. Now, when I get to this part, there is a squared button. If you see the math button down there on the left side, go 2 down from that and you'll see X squared. And so if you hit that, it just does the squared, and then it automatically puts your cursor back down so you don't have to use the right arrow. Plus, and then we can just keep going. All right. So once I do that, if you hit the graph button, you may or may not get something on your graph paper, okay? And the reason is my graph paper is set to show me just a certain amount. So if I go to the window function, what this is showing me is that I am looking, when I go to the window, that shows me what part of my graph paper I'm looking at. So I want it to be right over the origin. But, you know, if your graph paper is looking like over here and your graph is here, you're not going to see anything. So we want to make sure that my graph paper is where it needs to be. So I want it to be right, hovering right over my origin. So there's a couple of different ways that you can do that. So you can manually change it, the X max and X min. That is over here. Here is your X min, your smallest number, and this will be your X max. And then this will be your Y min, and the top one will be your Y max. So I'm wanting it to be like from negative 10 to 10 for this graph, negative 10 to 10. And that is a very, very common window. So when you go to graph and you hit window, see, mine's already set to that. If not, you can go in and manually set it negative 10 to 10, negative 10 to 10. Or you can come up here where it says zoom. Do you see right beside window? It says zoom. So if I hit that button, zoom, I could come all the way down here to the zoom standard, which is number 6. Zoom standard, and it sets my window automatically to this. And then it automatically graphs it. So there's my graph. What I'm looking for is where it is crossing the x-axis. And it looks like it is slam dunk on 4. See how it's going right through 4? Looks like it's going through 4. It looks like the x-intercept is going right in between 0 and 1, so about a half maybe. I don't know what this one is. And then this one, it looks like it's slam dunk going through negative 1. So it looks like for sure it's going through 4 and negative 1. Now the fractions, I don't know. But so it looks like maybe 4, maybe negative 1, maybe a half. Doesn't really look like it's going through 0, but maybe. So I'm looking at that, and I've got some guesses. Maybe negative 1, maybe a half, maybe 4. Could it be 0? If I look up here, do you see that I don't have 0 as a possibility? So it's definitely not going to be 0. But it could be negative 1, a half, 4, and there was another negative something in there. So I'm going to now check it. See up here it says graph on your calculator, and then match these possible zeros to what we guessed. So notice negative 1 is up there. It's here, negative 1. Half, that's in there. 4, that's in here. Okay, so I'm going to guess maybe, let's do -1 and 4 because I've got to put those on the shelf, right? We're going to check it using synthetic division. So I'm going to put -1 on my shelf. I'm going to put the coefficients of these guys right here, right? So I'm going to have an 8, -26, all those coefficients. I'm going to stick those right here. And I'm going to use synthetic division. So I'm going to pull down my 8. And then remember how we did that? We multiplied. And then put that number here. And then we're going to add. And then you continue to do that. Multiply and add. Multiply and add. Multiply and add. Remember, we wanted to get a 0 in that box, right? If you get a 0 in that box, then that means, yes, this guy is a solution. So we now know one of the zeros. That means we know a solution to that equation. I know an x-intercept. I know a 0. I know a root. Remember, all those mean the same thing. So they ask us specifically to find the zeros, okay? Find all the zeros. So we found one of them, right? 1 out of the 4. So now we're going to check. Let's check 4, right? We said 4 could be a possible one. So we're going to put 4 on the shelf. Remember, the key is don't bring down these guys. I don't want to bring down those, okay? Because I'm trying to go from x to the 4th. I went to x to the 3rd. So now I'm going to bring down all of these right there. And I'm going to do the same thing. Do synthetic division and hope that I get 0 in the box. So again, I'm going to multiply, bring down the 8, and then I'm going to multiply, and then I'm going to add these guys. And I did get 0. So yay, that's a 0. So now I've gotten -1 and 4. I've got 2 of my zeros. Now I could keep going. I could guess that 1/2, but do you really want to put 1/2 on that shelf? I don't want to put a half on the shelf. And notice I went from x to the 3rd. I am now at x to the 2nd. Well, we now know how to solve x to the 2nd. So I'm going to set this equation equal to 0. Right? I'm going to take these guys, set it equal to 0, and now solve it. Once it's squared, I could use the quadratic formula or could factor. I'm going to go ahead and factor. Remember, we're going to, for me to factor it, I use slide and divide. So I'm going to use slide and divide. You can use whatever you want. So I'm going to slide and divide. So I slide. I get those factors. But remember, it's slide and divide. So now I got to divide. So I divide by 8 because that's the number I slid. And then I reduced it. 2/8 is 1/4, and 4/8 is a half. So now I know my 2 other solutions, right? I've got that first one, x plus 1/4. That means that one's going to be a -1/4, and then the x minus a half, that's going to be positive a half. So I've got 2. So I now have all 4 answers. So I've answered the first one, right? The first one. Tell me all the rational zeros, and I've got 4 of them. That's as many as I needed. -4, 4, -1/4, and a half. So we've answered letter A, okay? We've found all the rational zeros. Now they want us to factor. So let's go and look at my answers. So I had x equals -1 and x equals 4. So remember, all I have to do is add 1 on each side for the first one. And that will give me x equals 1. And I subtract 4 on this side. And so I've got my 2 factors, x plus 1 and x minus 4. Where are my other 2 factors? Well, down there, I've got them. Okay, but they're not written in fact, they're ready to be solved. They're not factors. So do you remember what we do? We take this 4 and we move it up here, and I take this 2 and I move it up there, and that's the way I get my other 2 factors. Okay, now if you didn't use slide and divide, you would have already had those factors sitting there. So I have all 4 factors. I have x plus 1, I've got x minus 4, and then I've got those 2 factors. Now I just have to write them all out. So that's my answer to part B. I've got 4 factors. So when you have 4 solutions, you're going to have 4 factors. So we now know how to solve. Even when they haven't given us the zeros, you use your calculator and find out where it is crossing the x-axis. And you just guess, oh, it looks about like, remember, it looks like it's going to cross here. And then you check it. Yes, it did. Yes, it did. So I had 2 of my answers. And then I had gotten it down to x squared. So then I just solved it. You could have used the quadratic formula if you wanted. It was just easier for me to factor. Okay. So now you've got to remember that the number of factors, we just said this, the number of factors in your polynomial is going to be equal to the number of zeros. So we had 4 zeros here, so we're going to have 4 factors here. That's all this is saying. Okay, now we're going to go backwards. So I want you, in this particular time, you may have to stop the video, pause it, and figure out exactly what I was doing. Okay, so in class I would go slowly. I would be watching your eyeballs. When they start glazing over, I would review it a little bit. So you may have to just pause it and go back and rewatch this. Okay, because it's very algebraic. Okay. Anyway, so we're going to be going backwards. So now they are going to give us the zeros, and we're supposed to tell them what the equation is. So we're going backwards. They give us the zeros, tell us what the equation is. We have to tell them the equation. All right. So notice they say that it is a degree 3. So that means it's going to be x to the 3rd. So that means I should have 3 zeros, and they gave me 3 zeros. So I'm going to start off by, well, let's see what I'm going to do. I'm going to list my zeros. So here's my zeros. I find that this is the easiest. I make a little chart. So here's the zeros that they gave me. And then I'm going to use that 0. X equals negative 3. I add 3 to both sides, and that gives me this. So this is, so this right here is my first factor. Then I did the same thing to x minus 2, so that gives me the second factor. And then x equals 5, I subtract, and that gives me my next factor. So then I list all my factors, okay? So let's write out what we know so far, okay? So right now, we know that f of x is going to have these factors in it, right? So if it wasn't for this pesky little a right here, we could just FOIL this out. It's going to take a little algebra, and we would have an equation. Now, the problem is we have, let's say I had x squared minus 9. If I graphed that, I'm going to have 2. It's going to look like this. If I graphed it, it will be crossing at negative 3 and positive 3. Okay, if you don't believe me, you can pause it, throw it in your calculator, and you'll see that. Okay, now if I put a 2 in front of that and made it 2x squared minus 9, or let's say 4, just to make it even more fun. If I put a 4 in front, do you remember what that 4 does to it? It's going to stretch it out. Let's say to make it the same, I'm going to have to do this. Okay, so if I put a 4 in front of that x squared, If you do that and you plug it in your calculator, it's going to be really stretched, but it's still going to cross at -3, +3. So when you put that number in front, remember all it does is stretch it. It doesn't change the answer. So I could put all kinds of numbers in here. I could put a 4, I could put a 0.7, I could put not minus, it'd have to be positive. I could put I could put a 1/4, and that would make it flat, right? That would make it do something like that. Okay, but all of these would have the same answers, would have the same intercepts, but I could have an infinite number of equations. So they want a specific equation, right? So that is what this last bit of information is for, is to help us determine what a value is, that a value is. So this one is a little bit interesting. So notice what they gave us. They gave us a point. Okay, so this f of -1 = 6 that they gave us right here, remember, this is my x value and this is my y value. So I'm going to just plug it in. Okay, so I've got my x's. So here's all my x's right there and right here and right here. There's my x's. And here's my y value is right there. So let's plug those in. So I'm plugging 6 in for where the y is, where f of x is. I plug in that -1 where my x's are. And notice all I have left, everything is numbers, okay, except that a. So I'm going to simplify a little bit. I just simplified what was in my parentheses. -1 + 3 is 2. -1 + 2 is 1. -1 minus 5, that gives me my -6. And then I just simplify that. Notice that's going to give me what? -12? -12 right there. All right. So I've got 6 equals a times -12 divided by -12. My a value is 1/2. All right. So now I'm just going to plug that 1/2 right in here. And then we're going to be doing lots of algebra. Okay. So we've got, we're just going to plug it in. So now I'm going to have to simplify a little bit. I'm going to take this part right here. I usually just start at the end, and I'm going to FOIL that guy. So I'm going to FOIL that guy, leave everything else the same. Notice I went ahead and wrote this down. It's just now I'm going to FOIL him. So I distribute my, I'll do it in green. Distribute my x, and I get x squared minus 5x. And then I distribute my 2x minus 2x, and then 2 times -5. That'll give me -10. And then I'm just going to simplify that a little bit. So I get x squared minus 3x minus 10 from that FOIL. And now let the fun begin. We've got to distribute some more. I'm going to take this x and distribute it to this one. And then, hello. Whoops. Sorry about that. I hope that didn't mess me up too bad. Let me just go back. There we go. So, sorry. All right, so I'm going to distribute my x. So I get x to the third minus 3x squared minus 10x. And then I'm going to distribute my 3. So I get 3x squared minus 9x minus 30. So notice all I'm doing is lots of algebra 1, lots of distributing. So now I just have to simplify. So I'm going to come back through, and I'm going to simplify. Oh, that did not turn out well. Sorry about that. Okay, I'll just circle a little bit. So I simplified. Notice my x to the third. I just brought that down. And then I have my x squared. Notice those guys cancel out. Then these guys, just my x's, I'm simplifying that so I get my negative 19x. And then I have my minus 30. And then the last part is I'm going to take this 1/2. Let's see. Let me get a purple pen. So I've got my negative 1/2. And I'm going to distribute that. The way you distribute it is, notice that if I multiply this tops by tops, that gives me a negative 1x to the third, and then bottoms by bottoms. I don't have any bottoms down here, so everything is going to be over 2. So basically, I am changing the sign and putting a 2 on the bottom. So that's how I distributed that. So don't let fractions freak you out. Just put the 2 on the bottom. Okay. Now once I did that, this I can't simplify. This I can't simplify. But 30 halves, that's going to be 15. So now my f of x is equal to this big long thing. Okay. Now it wouldn't have been nearly as scary, I guess, if my a value had been like 2. Or if it had been 1, I would not have had to distribute it all. Okay. That's one that you might want to pause your video, go back, rewind it, and watch that part again, just to grasp how to do it. You will have one. You may have one like that on your test. Okay. All right. So the tip was to make your list of zeros. That's what didn't uncover. So I made my list of zeros. I turned them into factors, and then I used this little a point that I had to determine my a value. And then I just wind up multiplying this together. Okay, and distributing. So from this whole part right here is just it's algebra 1 on steroids. Okay. So now we're essentially going to do the same thing, but they're going to give you these factors in a different way. Okay, they're going to give you these zeros in a different way. They're going to talk about what's called multiplicity. Now, we're going to talk a whole lot more about multiplicity in the next section, but for right now, just remember that if I say I have a multiplicity of 2, that just means that whatever zero I have, whatever answer I have, like this negative 3 is an answer, a 0. If I say I have a multiplicity of 2, that just means I have that 0 twice. So here's an example. X squared minus 10x plus 25. If I factored that and solved it, I'm going to get an answer x equals 5, but I get 2 of them. So in Algebra 1, you just said, oh, that's an extra one, and you just crossed it off. Okay, and it didn't really mean anything. Well, it's going to mean a lot now in Math 110. So if I said I have a multiplicity of 3, that just means I have the answer 3 times. If I have a multiplicity of 4, that means I would have that answer how many times? Yeah, 4 times. So here's how they're going to state it. Find a polynomial of degree 3. So that's, again, they want you to find the equation, and it's going to be x to the third, that satisfies the following conditions. It has 4 is a 0 with multiplicity of 3. So all that means is I've got 4 3 times. So let's find the factors. So x equals 4. So x minus 4 is going to be my factor. And it's going to happen how many times? 3 times. All right. So then remember, I need to just set that, I need to just write out my equation. Now, I could have said x minus 4 times x minus 4 times x minus 4, which, is what we did up here, right? We took each one of these, wrote that down over here, wrote this down here, wrote this down here, and then put my a in front of it. I could have done that, but in this case, it's just easier to say it's to the third power. Okay, remember, we're going to use this point. That's a point. We're going to use that point to plug into the x and that's my y. Okay, so we're just going to plug it in. So here we did. I plugged the 24 in for there's my y value. Plugged it in for my y here. Plugged my x value, my 2, in here. And then I just simplify. So negative 24 is a times whatever negative 2 to the third power is. And again, that's just going to be negative 8. Negative 2 times negative 2 times negative 2. And then I'm going to divide. I didn't show that in my steps, but I would just divide by negative 8 on both sides, right? And I'm going to get a is 3. Thankfully, it is not a fraction, right? So my next step is to rewrite it, right? So now I went ahead and wrote x to the x minus 4 3 times, because you do not just distribute this negative 3. That doesn't work. Okay? So let me say that again, because that is a trap. That's a trap that a lot of people fall into. Okay? You cannot distribute that. Okay? So you've got to write out x minus 4 times itself 3 times. And what I'm going to do is I'm going to take those last 2 and I'm going to FOIL them. Notice once again that I'm going to take this guy and just write it down, okay? And then I'm going to take this guy and I'm going to FOIL it. So I went ahead and did that for us. So I got, I'm going to take x and distribute it here. I'll just do it with my, let's do that. So I said x times x is x squared. Then I got negative 4x. Negative 4x again, and then positive 16. All right, now once I do that, I'm going to take this guy and distribute this, my x, to everything in here. Might be easier to go ahead and simplify. Let's go ahead and simplify. So I went ahead and simplified because I had negative 4x and negative 4x. So let's go ahead and simplify, and now I'm going to distribute. So I'm going to distribute my x. Notice I'm leaving this. I just saved this guy for last, right? So I'm going to leave my 3 out here. I'm going to distribute my x to get x to the third minus 8x squared plus 16x. Then I'm going to distribute my negative 4. So I get minus 4x squared plus 32x minus 64. Now I definitely need to simplify some stuff in there. Notice that I've got some x squareds that are the same. I've got some x's that are the same. So let's simplify a little bit. So there's my, notice I left my 3 out there. I don't have any more x to the third, so I just wrote that down. Then I've got my x squareds there, and I combined those. I combined my x's and got 48x. And then I just have that minus 64 left. So I've simplified. Last step, right? My last step is to finally distribute my 3. Okay, I'm going to distribute my 3. Whew, that's my final answer. Okay, so these last 2 problems, 3 problems actually, these last 3 problems, no, 2 problems. The last 2 problems, the difficulty really has just been doing all the algebra, right? Of just distributing and not making careless mistakes. Okay, so we've got just a little bit more to go. I want to remind you what x squared is, right? Anytime you have an x squared, you're going to plug in negative 1. We're going to multiply some complex numbers, getting you ready for the next part. So just a reminder, you're going to FOIL it just like we have FOILed these guys up here. You know, when we FOILed these, we're going to do the same thing. We're going to FOIL these guys, and then we're going to simplify this, what's in the middle. So we'll get 12 minus 7x. And notice what I did. I had this minus, I had this minus x, minus 10I squared. Well, minus 10I squared, that I squared is just a -1. So all we do is just change that sign. And then I'm going to simplify a little bit further. So I get 22 minus 7I. So whenever you are multiplying two imaginary numbers, notice you're never going to have an I squared in your answer. You're always going to simplify. Okay. Now let's do this next one. Notice that this guy is exactly the same, 5 minus 7I, 5 plus 7I, except for the signs in the middle. So when that happens, something special happens, right? So I'm going to go ahead and FOIL that out. So I got 25 plus 35I minus 35I minus 49I squared. Notice that my middle two guys are going to just cancel. So I then get 25, and I'm going to change that to plus 49 because, again, this I squared is going to turn into a -1, which just changes that to a positive 49. So then when we add those together, we get 74. So notice the really cool thing. When you multiply these two together, you no longer have an imaginary number. So those are special. Those are called conjugates. Okay, they're called conjugates. So notice the only difference is you just change the sign. So when this one, if this one had been 5 plus, let me do something different. Let's just, because we just did one that was a 5. Let's say 2 plus 3I. The conjugate would be 2 minus 3I. So that's just going to be A minus BI. So A plus BI, A minus BI. All that's saying is just flip the sign, change the sign, and those are now conjugates. All right. So, so my version, I just pretty much said my version. So if you have this, the conjugate zeros theorem says if this is an answer, if this is a solution to your equation, then 2 minus 3I is also a solution to your equation. All right, so let's use that. They're asking us once again to find the polynomial. So they're going to give us zeros. So they gave us -4 and they gave us 3 minus I. And they want us to find a polynomial of least degree. Okay, so here's my question. Hello. Whoops. Don't know how that happened. Okay. So, what solutions did what zeros did I have? So, they already told me I had a -4. They also told me I had a 3 minus I, but that also gave us the third root, the third zero, which is 3 plus I. So if you have 3 minus I as a 0, you will also have 3 plus I as a 0. Now we got to change those into factors. So we know how to change the x equals -4 into a factor, right? We just add 4 on both sides. Okay, so now we're going to do the same thing with the 3 minus I. So I'm going to say x equals 3 minus I. And then I'm just going to subtract 3 on both sides and add I on both sides. So it looks weird. It's a weird factor, but that's okay. It was a weird 0. We're going to do the same thing with my 3 plus I. So now I've got all my factors. Now notice, they did not give us anything that said, f of -1 equals 7 or something like that, right? And that's because they said they want it of least degree, having only one real 0. And they said find a polynomial function. They didn't say find one that has this, that has a certain a. So they just want one of them. So we're just going to assume that a is 1 and not worry about it because we have enough to distribute, right? So here we go. We have to grab all those factors and multiply them together. Now, there is a shortcut. And I've had students in the past that are like, that shortcut's a little bit hard, Miss Kitts. I'd just rather take this and distribute it to these 3 guys. And then take this and distribute it to these 3 guys. And this, and that gives you a long thing of 9 terms, and it never turns out right. I'm just telling you, it never goes well. So, the best thing to do is to actually use the shortcut. Again, it's just a pattern. So here is my pattern. First, we've got to figure out what these a values are. What is this a that's in here? Right? And I write it in because I've got it twice in my formula. And then what is my b value? So let's figure that out first. So my a value here is 3. Notice that that is... that's going to be this value here. So there's my a value. Notice my b value. So I've got, might help if I write it out. 3 minus I was one of them, and 3 plus I was one of them. So here is my a value. And then my b value is the one that's with that's with the I. Now notice that one of them's negative and one of them's positive. So which one do I use? It doesn't matter because if you look in the formula, we only have it in there once and we square it. So it doesn't matter if you plug in -1 or +1, you're going to get 1 squared. And then I'm going to have just my b. Again, it's a pattern. Just practice it multiple times until it gets in your noggin. All right, and now let's simplify a little bit. I'm going to continue to keep this guy. Just going to write that guy again. And then I'm going to simplify. So I'm going to multiply 2 times 3 and get my 6. 3 squared is 9. 1 squared is 1. So that makes it much simpler than having a long string where you had to distribute. I'm going to simplify this in the middle. Notice these guys can combine. 9 plus 1 will give me 10. So simplify that. And then finally, I just need to distribute. I'm going to distribute my x first. Let's distribute him first. So I'm going to get x squared. Yeah, let's do that. So I'm going to get x to the third minus 6x squared plus 6x. And then distribute my 4. So I get 4x squared minus 24 plus 40. And then finally, I just combine like terms. So my x squareds I combined. So I left my x to the third I couldn't do anything with, right? And so my x squareds I combined. Now I'm going to combine my x's. So 10x minus 24x gives me minus 14x. And then my plus 4. So that's my final answer. They asked us to write an equation in least degree. where if I solved it, I would have three solutions. I would get x is -4, and then I would have my imaginary answers, right? My complex number answers. All right, one last problem. We saved the best for last, right? Okay. You may need to pause and go get you some Mountain Dew. All right. But one last problem. But notice they're asking us to find all the zeros given 1 0. So first question is, how many zeros are we looking for? Hold on, let me go back. Sorry. First question is, how many zeros are we looking for? So we've got x to the 4th, right? So we are looking for 4 zeros. How many have they given us? Okay, well, it looks like they've given us 1, right? 2 plus I. But remember, the conjugate zeros theorem means they gave us 2. 2 plus I, and we know that 2 minus I is also a 0. So remember, we have 4. We need to get down to an x squared. It's x to the 4th. We need to somehow get it down to x squared so we can either factor or use a quadratic formula, right? And we now have 2 solutions, right? 2 answers that we can put on the shelf and get down to that x squared. But notice what's going to be going on the shelf. Yeah. My 2 plus I. We're going to start with this guy. We're going to put 2 plus I on the shelf. Here, we're going to use all these coefficients. So I got a 1, a -1, minus 17, plus 55, minus 50. Notice I'm not missing anything, so I didn't have to put in any zeros. Well, now the fun begins. Remember when we got to do that before? It was so much fun. I could tell your eyes were glazed over when I was working it. But again, what are we trying to do? We're trying to get what in that box at the end. We want to get a 0, right? Now, they promised us that we would get a 0 because they said that 2 plus I is a 0. So that means I should get a 0 in my box. So I'm going to go ahead and put it over there. And if I don't, I have to go back and fix something, right? Okay, so I pulled down my 1. Remember, you're going to multiply. That's our steps. Multiply and then add. Okay, so I'm going to multiply 1 times 2 plus I. And I get my 2 plus I. And then I'm going to add. Notice I can't do anything with my eyes, but I can say 2 minus 1 gives me 1. So I get 1 plus I. Now the fun really begins because I get to multiply this 2 plus I that's on the shelf with my 1 plus I. So I went ahead and did that for us. So notice that we are going to FOIL. So 2 times my 1 plus I. I'll do that in green again. Let's use a different green. So 2 plus 1 is 2. 2 plus I is 2I. 1 times I is I. And then I have my I squared, which turns into -1, because remember that's saying plus a -1. And then I keep simplifying, so I wind up with 1 plus 3I. So I'm going to put that on the big old line up there. Now, again, I can't do anything with my eyes, but I can say -17 times 1, plus 1, is going to give me -16. So I got -16 plus 3I left over. What do we get to do again? Multiply my 2 plus I times my -16 plus 3I. Y'all are going to be pros at multiplying these complex numbers by the end. Okay, so I did the exact same thing. I'm going to FOIL those two. Again, at the end of my FOIL, I get an I squared, which all that means is I'm going to take that plus 3i squared that I got at the end, and I just change it to I change it to a minus 3. Simplify by taking the minus 32 minus 3 more, so that gives me minus 35. So when I multiply those two together, I get minus 35 minus 10i. I'm going to put that back up on in part of my synthetic division. I can't do anything with the I, but I can say 55 minus 35. So I wind up with 20 minus 10i. And then my last step is to multiply what's on the shelf, 2 plus I, times what I just got, 20 minus 10i. And I'm hoping that I get what right here? I'm hoping I get a 50 there, so that a minus 50 plus 50 will cancel and I get a 0. So let's see if that's what happens when I multiply them. So when I pull that out, notice that my middle two cancel. My minus 20i plus 20i is going to cancel. My minus 10i squared changes into plus 10. And I do get a 50, so I get my 0, which is great. That means I didn't mess up. Okay, now the whole reason we are doing that, why in the world did we start off doing that? Remember, we're trying to go from x to the 4th down to x to the 3rd, which we did. So now I'm going to put plus minus I on my shelf, and remember, I'm going to take my coefficients, the ones that I just got. That's what I'm going to put for the next synthetic division. That goes right. And I'm going to do the exact same thing again. So I've got to pull down my 1. What do I want to get in my remainder box? I want to get a 0. Not only do I want to get a 0, they promised I would get a 0 because they said 2 plus I was a 0. They promised that, which the conjugate zeros theorem says that 2 minus I is also going to be an answer. So I got to basically do the same thing again. I'm going to multiply my thing on the shelf, 2 minus I, times my 1. But notice what happens. It's going to be much easier this time than the last one because my i's just cancel out because I have 1 plus I, 2 minus I. My i's cancel out, so I just get 1 plus 2. That's going to give me 3. That's all I got down there. Yay! All right, now I've got to do it again. I've got to multiply my 2. Whoops. I got to multiply my 2 minus I times 3. And when I do that, I get 6 minus 3i. Again, my i's are going to cancel. So minus 16 plus 6, that's just going to give me 10. Then I'm going to multiply one more time. Multiply my 2 minus I times negative 10. And I get minus 10 plus minus 20 plus 10i. My i's cancel. So not only do my i's cancel, but so do my 20s. So I did get a 0 there. Okay, so again, why did we do all that? Because we're trying to get from x to the 3rd to x squared, which we did. So we're going to have x squared plus 3x minus 10. I'm just going to take that and I'm going to set it equal to 0. And then I solve it. And I believe that one factors. Yep, it factors. So I have x minus 2 times x plus 5. So that means I have My x minus 2 gives me one of my answers, x equals 2, and x plus 5 gives me my other answer, x is negative 5. So they ask us, what in the world was this? What was the question? So the question was to find all the zeros. So that means I've got to list 2 plus I and 2 minus I, as well as the two answers that I just figured out. So all my answers, it's going to be 2 plus I, 2 minus I, and then I just found 2 and negative 5. The sad part is if you do all that work and you just put those two answers in and don't list these first two answers, the 2 plus I and the 2 minus I, my lab will count it wrong. So make sure after you do all that work that you list all the zeros. All right, so we have finished with this section. So again, the good news is you have this recorded. So you can go back if this confused you at all with all the distributing. Usually that is where my students' eyes glaze over, and I basically keep going even though the eyes are glazed over and say the only way you're going to not have glazed eyes is if you go back and work this again yourself. So go back and work this again. Okay, you can print off another sheet if you need to. Work it again so that you understand what I'm doing with all this algebra. I'm just distributing a bazillion times. Okay, again, if you have any questions, feel free to email me. I will go over any questions the next time we have class after the test. So I've set aside about 10 to 15 minutes to go over questions from this section. If you have not done the homework, you won't know the questions to ask me. So at least attempt the homework, even though it won't be due until after you've had a chance to ask me questions. That's it. I will see you at the next class.